Now that we have seen how to change a vector's magnitude to be any value, we will learn how to change a vector to a very specific value, the value of 1. This becomes then the unit vector. You might remember when we did those special triangles, we created this unit circle so that the hypotenuse was always 1. Similar idea here. This will give us a direction. A unit vector is a vector that is 1 unit long. The unit vector of, let's say, vector v will look like this. We put a caret or hat over the letter instead of the vector symbol. And all we do is take the vector, which has components to it. We only deal with 2 dimensions. If we had more dimensions, there would be more letters, I, J, K. And then we divide by the magnitude of it, of the vector. So to create a unit vector, we divide a vector by its magnitude or length. There we go. So second part of the lesson. It's going to look a little complicated, but I think when you get the general idea, it's going to work out pretty straightforward. X and Y are the components of the unit vector for vector A, which has a magnitude of 5. The direction that this goes is 4 units to the right and 3 units up. So that's what X and Y are for the vector A. For the unit vector, we're going to want to find this lowercase x and y here. And to get that, it's useful to find the angle. In this case, 36.87 is the angle. And you might get familiar with that with a 3, 4, 5 triangle. These angles show up a fair amount. And a note to make is that the hypotenuse of the red triangle is the unit vector, which goes in the direction of the green vector, but is not 5 units long. It's only 1 unit, and that was that length we wanted to have. And so when we look at the green vector, or hypotenuse here, starting from this vertex down here in the bottom left, we would say that vector A has a horizontal direction of 4, vertical direction of 3. We use I and J for horizontal and vertical. And if you looked at the trigonometry here, you'd notice that cosine of 36.87 gives the amount of the magnitude that is only horizontal, and sine times that angle gives us the vertical component for that magnitude of 5. To look at this unit vector, and that's a term you're going to have to get familiar with, the book uses this notation, U with a vector. Typically in physics, because you're going to deal with more than one vector, to have U designated as the unit vector for any one vector forces you to be stuck dealing with just one vector at a time. But by using this notation, A with a hat over it, you'll know that the direction is the same as whatever vector I tell you, if it's A, B, C, whatever. And then the hat over it says it has a magnitude and direction. The magnitude is always 1 unit. The direction will be defined by the coefficients for your horizontal and vertical directions. So in this case, you take the 4 units horizontal and divide by the magnitude 5, as well as the 3 units vertically and divide by the magnitude of 5. And that'll give you lengths that are obviously less than 1, but when you square them and sum them, you'd get a hypotenuse of 1. In trigonometry, we would have used those values, the cosine of the angle and the sine of the angle, to get horizontal and vertical. Okay, so this is going to be the definition we've used already, where we had the vector v divided by the magnitude. This is going to deal with your trigonometry. So let's find a unit vector for vector v. In order to do this, we'll use our definition, which will look like vector v over magnitude of vector v. And we would get 3i plus 4j all over 3 squared plus 4 squared divided by, square rooted is 5, which would just give us 3/5 I plus 4/5 j. And of course we just did that. That's the unit vector. To find a vector of length 10 in the direction of the original vector v, we would simply take our unit vector and multiply it by the scalar 10. So 10 times the unit vector is going to give us this, and that's 10 times 3/5 I plus 4/5 j, which, if you do some fairly quick canceling out, the 5's cancel, this becomes a 2, we get 6I plus 8j. Now you might have noticed that 10 is simply double what our magnitude is. So if you wanted to take a shortcut, you could have just doubled the 3 and the 4 and gotten the same answer, but that will typically not be the case. You might have noticed that 10 is simply double our magnitude of 5, and you could have just simply doubled each of the components and gotten the same value because this is essentially a right triangle. It's a similar triangle. So you could have just doubled 3 and gotten the 6, doubled the 4 and gotten the 8. Typically you're not going to get integer values that you're going to make larger. For instance, the problem you're about to do. I want you to try this. Find the unit vector first and then find a vector of length 7 in the same direction. Okay, first we're going to find the unit vector. That's simply going to be 5 over our magnitude. In this case our magnitude is 25 plus 4 square rooted minus 2 over root 29 in the j direction. And to rationalize, which may not always be required here, but it's good form, we get this value. This is our v hat. All right. So if we want to find one with length 7, we simply take our unit vector and multiply the components by 7. Not a real challenge here. 35 root 29 over 29 I minus 2 times 7 is 14 root 29 over 29 j. Hopefully you don't find that too challenging. But of course this is just getting familiar with finding these values. Using them can be a little bit trickier when you get into some of the problems. Here's some on your own. Go ahead and give these a try and we'll see you in class.